Welcome to Digital Toolbox. This is the fourth installment of our polysurface waffle definition. So last time we left off right here on the third video, and now we can toggle the individual struts, and you can see those repopulate. We can also toggle the material thickness to adjust whatever the material thickness we want to fabricate it is going to be. And that leaves us at these extrusions, these last buttons that we did in the last video. So these are those individual struts, and to make our joints we're going to use the bounding box just like we used the first time. Copy and paste that down, and that will give us a box over each of these. Just like our original bounding box for the geometry, we're going to use the same method. So the next thing we're going to do is our box component, our box corners, goes hand in hand with the bounding box. I'm just going to do this for the top one to get the feel for it first, and then we can copy it down. And then the box corners, we want to move this bounding box up halfway. So we're going to analyze the same distance, get a distance button, and this distance will be that vertical A to E distance we used earlier in the definition. And then that distance, we want to move it in the Z vector, the Z unit. Except we want to reduce it down to one half that total distance. So I'm going to double click and grab a single variable definition, a single variable function, and that x will be that distance, and then the x will reduce through division, x over 2. You could use a division for this, that'd be the same thing. And just for kicks, so I don't forget, I'll do x over 2 in the name, and then connect that to the Z, and then the next button we have to do is just move it. So I'll get a move, and this x over 2 Z vector will be our T translation vector, and then the geometry we want to move is the bounding box, which will difference out. So that's the bounding box right before the box corners, and you can see in Rhino that it's moving those guys up, and it's creating that flat level plane on the interior. So that'll be the same for the lower portion of the definition. I'll just copy those last 5 buttons and drag them down, throw in the box corners for the opposite ones, and then the translation vector is still attached. The geometry we want to move is the lower bounding box, so we'll reconnect that, and you can see it's moving both of them up. That lower bounding box, we don't want it to be a positive Z move, we want it to be a negative Z move, so we can just go into our function and do a negative x over 2, say OK, and then to remain consistent we'll put a negative in the function name just to remind ourselves how we did it. And here are the individual moves. So we'll take these moves, these move buttons, you can see them highlighted as the boxes, and then difference those out of the extrusions, the actual discs, and that will give us our discs with the notches cut into them. So right after this move, I'll double click on find a difference, a solid difference. It's in the intersect column, and the A on the difference will go back to our original extrusions right before the bounding box, and then the B on the difference will go to our move. And then you'll be able to see in here, if we unpreview the rest of the stuff, that it'll start to difference out that stuff. difference out the notches. Except it won't difference them all out unless we flatten this series. So I'm going to right click on B and flatten it, and that should do it. It'll take a little second for it to kick in and think about it, but we're just going to copy and paste the same difference down below, and it'll be the same method except the B goes to the top move and the A, zoom out, goes to the bottom extrude. So after that, I can turn off the moves. I'll unpreview those, and I'll go ahead and unpreview the bounding box, and the box corners. And here you'll be able to see the difference taken into place when I bake it. I'll just select one of them and bake one. And there you can see all of those taken out and these individual notches to complete the waffle. So that's it for the waffle. We'll come back in and lay out these vectors to on a plane to fabricate, laser cut, or any other digital fabrication, and then that'll be it. So thanks for watching, and if you have any questions, or if this doesn't work on if this definition doesn't work on your version of Grasshopper, please let us know. We always love the feedback. So give us a email at Scott or Tam at digitaltoolbox.info, and thanks for watching.